Thank you for your introduction, Suzuki Sensei. And today's title of my talk is Overview of Electrified Vehicle, Electrified Mobility and its Impact on the Smart Grid. And so in the first part of this class, Inaki Sensei always talked about how to exploit the vehicle use information for the energy management systems. And he already showed some typical application for the home energy management systems. So in my talk, I'd like to first of all talk about the overview of the trend of the electrified mobility in Japan. It's very kind of a general talk, not so far from specialized technical talk, and it will be a very, very general talk as first part. And so let me talk about the categorization of the vehicle and the prediction and what type of vehicle is promising in 2030s in Japan. So it is very interesting question particularly for the OEM makers. And second part, I'll talk about a bit technical part, integration of smart grid and mobility by using EV and PHV. That's a part of the Japan JST CREST project, which is organized by me and of course Professor Inagaki. And this includes so many technical challenges, and I'd like to introduce about how the electrified vehicle will be exploited for the future energy management system for society. Okay. So this is the first part. So this is just a categorization of electrified vehicles. So if you already some expertise knowledge about the vehicle, so maybe that kind of students will know much about this than me. But I like to show you this as an introduction of this table. Okay, so the categorization of electrified vehicle is like this one. So typical ones, most famous one is HV, it's hybrid vehicle like a Prius. And PHV is a plug-in hybrid vehicle, and the BEV is a battery EV. And this is commonly used, commonly just says EV, okay? And there's no engine here. And the next one is a battery EV with RE. RE means range extenders, And this is FCB, fuel cell batteries. So this is a rough categorization of the electrified vehicle currently existing in the society. And the driving force, the hybrid vehicle driving force is engine and motor. And the plug-in hybrid vehicle also engine and motors. What's the difference between these? As a PHV has larger size of batteries compared with HV. That means PHV can be regarded as a combination of the pure EV and the hybrid vehicles. That is a PHV. And BEV has no engines. That means the driving force is only in the motor itself. So the one of the drawback of the BEV is that the driving range is a bit smaller than the case of the engine ICV vehicles. So in order to overcome the kinds of drawbacks, so BEV with range extender is now installed. For example, typical ones are Nissan Note, maybe you know, the Nissan Note BEV with range extenders. But here, range extender means kind of small gasoline engines. Maybe its size is about 0.5 liters. So maybe small size gasoline engines. So this gasoline engine is not used as a driving force, but used for the power generation for the motors. That means in the case of the batteries almost run out, so this generator can provide the power by using the small generator. So that is the advantage of the BEV with range extender systems. That is why it is called range extension. Okay, range extenders. The range extender is the same as battery, with small size gasoline engines. And the last one, the FCV. So this is totally different from these vehicles because fuel source is hydrogen, so it's quite different from the not gasoline, not electricity, the fuel hydrogen. So it is very promising from viewpoint of the environment friendly vehicle, but there are some lots of problems, as you can easily imagine. So there is, at this moment, no enough number of hydrogen stations in the society in Japan. So that is one of the biggest problems. Okay? So this is a categorization of the electrified vehicles. And it's also the comparison of the structures of these electrified vehicles. Okay, so Toyota Motor Corporations regards that the structure of the hybrid vehicle can be transferred to any other type of electrified vehicles. Okay, so this is the structure, the basic structure of the hybrid vehicle like a Prius. So it has an electric motor, the power unit control unit, and batteries, and the gasoline engines, generator, and fuel tank of gasolines. So thanks to this structure, so that this hybrid vehicle can extend the driving force even if the battery is very small size, because it has a gasoline engine and generators. It can provide enough electric power to these battery systems. So, and if we enlarge the size of batteries like this one, so this now switch to transfer to the PHV. The difference is just the size of the batteries between the PHV and HV. And also the PHV has a pure EV mode. Pure EV mode means that just it can drive by only using the battery itself. So there's no necessary the assist of the generators, engine generators. So that's one of the advantage of PHVs. But the main structure is almost same. The size of the battery is a bit different compared with HV and PHV. And the BEV has the simplest structures among all these categories. So maybe it's this, because gasoline engine, fuel tank of gasoline, this part can be completely removed from the vehicle. So that means the battery and the motor, that's the only component which is necessary to drive the battery EVs, BEV. So it has a very, very simple structures. So in this case, maybe the almost 70 or 80% of the volume of the vehicle is occupied by the batteries. So maybe you can easily imagine the Nissan Leaf has a very, very big size of batteries, which can be occupied 70 or 80% of the volume of the vehicle itself. So that's one of the features of the BEV. And this is a FCV. So FCV has also very complex structures like HV, because this part is replaced by the fuel cell and the fuel tank of hydrogen with high pressures. So, and the other remaining part is almost same as a BEV. So only the power source for the electricity is different from the compared with the BEV. So this is direct charging. This is generated by the fuel cell. That's the only difference. Okay, so this, like this, and Toyota Motor Corporation considers that HV hybrid vehicle can be a fundamental structure for any other type of the electrified vehicles. That's why the TMC is now mainly focusing on the development of hybrid vehicles. And also, this is a proposal by Toyota Motor Corporation again, and which type of the electrified vehicle is used for some particular purposes. Okay, so Toyota promotes to use various type of electrified vehicle according to the size of the body and the travel distance. So maybe they say that the travel distance and size of body should have some strong correlations. So that will be very good use for the different types of the electrified vehicles. For example, the size of the vehicle is very small, like this one. So maybe you can see that this is a very famous one-person ride electric vehicle called COMS, C-O-M-S. And maybe this is mainly usually for the short delivery, because it has a very small driving distance and small batteries. But it's very convenient, so easily park at anywhere, so easily drive. This is a kind of maybe short delivery or short, for example, the EV sharing system, something like that. And on the other hand, the HV and PHV are used as a passenger vehicles, and is mainly used by as a possession car by normal person, the family type passengers vehicles. And the last one, the FCV, which is used for the heavy truck or delivery trucks, which is very heavy sized vehicles. So in this case, maybe the type of the fuel will be replaced from the gasoline to the hydrogen. That's the insist of the Toyota Motor Corporations. Okay, so this is a map of the use of the different types of electrified vehicles. And also this slide shows the target number of the electrified vehicle by the predicted by Japanese government. So it's now almost 2020. So this was made by maybe 5 or 6 years ago. And the occupation of the hybrid vehicle should be 25% in 2020, and the PHV plus BEV should be about 20%, FCV 1%, clean diesel 5%, total low emission vehicle 50%. That is a prediction of government 5 years ago. But I'm not sure this is not satisfied. This is not achieved yet. Particularly the PHV and BEV, number of the percentage of BEV is much more smaller than 20% at this moment. So maybe this is about 30% or something. And it's also the government, not prediction, maybe it's the government's desire, maybe, by 2030, always PHEV plus BEV should occupy 30% of all the vehicles. But I think it's quite questionable predictions. Maybe this will not be achieved because of the very slowdown of the implementation of the battery electric BEV in Japan. In 2050, but this is not prediction. This is just a kind of desire, not desire, maybe dream or something, I think. So in the case, the total of the low emission vehicles should be more than 95%. That's a government policy in Japan. Okay. I think that also the Toyota's prediction is almost same, and in 2050, maybe the 95% should be replaced by the electrified or carbon-free vehicles. And nowadays here, around here. But I think the curve is a bit slower. The slope of this curve is more kind of a smoother as a real implementation stages. And I think one of the important component to decide what kind to decide the accelerate or decelerate the implementation of the electrified vehicle is the performance of the batteries. Performance of the batteries. It is very, very important bottleneck for the battery electric vehicle at this moment. So this is a profile of the energy density of the lithium-ion battery per years. So it's a bit very old data because it's ended at 2010. So maybe nowadays a bit still keep increasing already also. And but if this curve is rapidly going up, then maybe the number of the BEV will be more occupied in Japan and also in the world, of course. And but this is a kind of maybe keeps the same performance. I mean, it is already saturated. So maybe hybrid vehicle or plug-in hybrid vehicle will be one of the dominant electrified vehicle in Japan or in other countries. And if but not going down, but maybe it's keep saturated, or there will be some breakthrough or something. So one of the challenging technology to make a breakthrough for the battery performance is say the all solid state lithium-ion batteries. It says that it can potentially can be 4 times as large energy density as the original lithium-ion batteries. So if this is truly realized, the number of the EV will be more accelerated in Japan. So this is one of the key technologies to accelerate the implementation of the EVs. And so this is another viewpoint, the why the EV is not so populated in Japan. So one of the leading country to install the EV is Norway. No, it's Norway and China. So, but if you consider that Norway is not car-making countries, it is car-using countries. So China is a car-making country. So as a government policy, so they are very focusing on how to exploit, how to overtake the Japan and Europe countries in the case in the field of the vehicle technologies, because the ICV or hybrid vehicle or PHEV, so China has some drawbacks in the development of very complex technologies. But EV is very, very simple structures, so they have a chance. They have a chance to overtake the Japan and Europe. So that's why the China is focusing. China government is focusing on the development of new EV systems. And this is a case of Japan. Why hybrid vehicle in Japan rather than the EV? So as I showed in the previous slide, so Toyota Motor Corporation has truly enough technical potential to implement the EVs in the community or society. So if they want, so they can do it. Why they don't do it? Why they keep insisting on the hybrid vehicle or PHEV? That is coming from the structure of the industry in Japan. So Toyota hybrid vehicles price was reduced in 1999. And now the 50% of new car sales are hybrid vehicle in Japan. The hybrid vehicle are promoted more than EV from viewpoint of the structure of the automobile industries. Okay, so let me explain about this point in detail. So this is a comparison of the number of the components which is necessary or implemented in the vehicles. In the case of a hybrid vehicle, it says about that about 33,000 components necessary to assemble the vehicles. On the other hand, in the case of the EV, pure battery electric vehicles, just the number of components will be 10,000 to 20,000. So there are maybe the one third of the hybrid vehicles. And this is also the structure of the automobile industries, Toyota Motor Corporations. So this is a primary Toyota Motor Corporations, and the Toyota Group itself has employees about 407,000 407,000 employees. And this is the primary subcontract companies like suppliers, like for example, Denso, Toyota Jidoshoki, Aishin or something. There is about 5,204 companies contracting as a first tier one suppliers. And also, under the tier one suppliers, there are secondary subcontract companies of more than 25,000. So in the case of the total number of the employees in contracting engineers is 1.5 million. Okay, so worker population in Japan is 63 million. So there is maybe the 1/16th, 40 分の1 is working at the Toyota groups. So this is a reason why the hybrid vehicle is popular in Japan. So because thanks to the number of the components, huge number of components, the Toyota group can distribute their profit to these supplying companies, supporting companies. That's one of the biggest reasons. So that's also the government policy, because the government must protect the employment, keep employment, rather than implementing the new technologies. Okay, so in this case, a hybrid vehicle is very plays an important role to support the Japanese automobile industries. So if this is suddenly drastically changed from this one to this one, so maybe so many companies will lose a job. So many workers will lose a job. So then, what kind of them? So in that case, these employers, what kind of new other type of job so these employers will do? So it's very difficult government problem. So that's why the HV is so highly promoted at this moment in Japan. So, but if we can find some job or work for these engineers, even in the case of the EVs, maybe this system will be more and more accelerated. So that's another reason. And also, this is a comparison of the cost of the BEV and HV in Japan. Of course, the cost for the vehicle is highly dependent on the price of the energy. And this is a profile of the price of the energy. So blue one is the price of natural gas. Red one is the price of the oil, 石油ですね。これがガソリン。Okay? And the green one is the price of the coal, 石炭です。So as far as seeing this picture, so it's a bit going down from the 2010. So maybe, so we need to clearly consider to compare the cost of the EV and the HV. But so this is just a sample case of the comparison of the cost in the case of using Nissan Leaf, and Toyota Prius. Okay, so the body price of the Leaf and Prius written here. So price is a bit in Nissan Leaf is much higher, a bit higher than the Prius, but it has at this moment tax exemption. I mean the advantage of reducing some taxes, maybe described anywhere. I'm not sure. Yeah, and also. Here, yeah, okay. So the tax for 7.8 is a bit different, smaller compared with the Prius. That is the advantage of the electric vehicle in Japan. And also, this is a profile of the total cost, comparison of the total cost. The red one is Prius, and the blue one is Nissan Leaf. So horizontal axis is the price of the gasoline. The vertical axis is the total cost. Total cost includes an initial cost. Initial cost means the buying cost and the running cost and the tax for 7 or 8 years. Okay, so this is the total cost. So that's a comparison. So because Leaf does not need any gasoline, so it's constant for the gasoline price changes. But the Prius case, so if the gasoline price will increase, maybe it also increases. And currently, the gasoline price is about 130 Japanese yen for 1 liters. In that case, maybe the Prius has a bit advantage in the case from viewpoint of the cost effectiveness compared with the Nissan Prius. But if it's much higher than the 180, gasoline price is more than 180 per 1 liters, so maybe Nissan Prius has advantage from the viewpoint of the cost effectiveness. Okay, so there is a sample comparison. And also another important application of the battery electrified vehicle, a battery EV, is a small BEV and its application to car sharing services in Japan. Car sharing services in Japan. Because in the case of the car sharings, maybe small size car sharings, the driving range can be limited. Driving range can be limited. Like, for example, only inside some, for example, Anjo City, inside Anjo City, or inside Toyota City or something. So in that case of the purpose, maybe we don't much worry about the driving distance shortage in the case of the EVs. So now that this is a profile of the progress of the car sharing services in Japan. So it's rapidly going up from 2010. So, but this is not only including the EVs, but also including the car sharing service using the ICV. ICV means engine, gasoline vehicles. And so this is just image of the short distance sharing by using a small battery electric vehicle. So it can provide a service of the transportation from, for example, from city office to the station, or from school to the station, or from bank to the station or something. So this is very, very short range, small electric vehicle sharing systems. So this will have some potential advantage to be implemented even in Japan. Because the number of the vehicles are limited and the number of the distance, the range of the driving distance will be also limited. So that is one of the biggest reasons to this kind of service will be very beneficial for using the electrified vehicles. And actually, so we have four or five already demonstrated field tests of one-way type small battery electric vehicle car sharing services. One-way means it's a very, very unique, not unique, but very, very one of the difficult services from viewpoint of the providing the service. Because one-way means the start point of the sharing vehicle and the goal point can be different. That is one way, definition of one way. Round trip means that the start point and the goal point must be same. So in that case, the vehicle is distributing, keep distributed sufficiently at any time. But in the case of the one way, because the starting point and the goal point can be different, so after some time durations, the vehicle tends to gather at some specified charging station, EV stations. So in that case, we need to reallocate the vehicle from the gathered vehicle to original different positions. Okay, so that's one of the biggest problems. So anyway, but in Japan has a field test of one-way type small BEV car sharing services, like sorry in Japanese, Choimobi in Yokohama. This is organized by Nissan Motor Corporation. Number of cars about 100. So Nissan New Mobility Concept. So this kind of very small vehicle is used. And IMEB is also used. This is a Mitsubishi Motor Corporation. It's a Kobe, but the car is 15 and the station is 20. And also Hamo is very, very famous one. The Toyota City and the Tokyo, they have more than 100 cars. And the Komusan Road is iRoad is this one. It's a very unique type small vehicle. This is used for the demonstration of the one-way sharing services. And also Kimobi. Kimobi is organized by Denso Corporation, also used on Comus by the 30 number of the vehicles. I think at the last time maybe it's more than 30, but yeah, it's not 30. At the beginning it was 30, and the number of stations 35. So these are field tests of one-way type small BEVs, and they are considering. So is this possible to create a new service or some business model or something. And so they are strongly interested in this kind of achievement. And this is another topic and about the categorization of battery chargers. And so these are very technical and electric system-oriented technical topics, but as a fundamental knowledge, you better know about what type of the battery charger is existing in the world. So roughly speaking, battery charger is classified into the two types, the AC charger and the DC chargers. And from the viewpoint of the fast charging, so maybe DC charger has advantages. But the size of the DC charging stations as a result much more bigger than the AC charging systems. Okay. And so in Japan, I think the AC charging system with double speed AC charging systems and also rapid charging DC charging system. This is called CHAdeMO charging, mainly implemented in the EV charging stations in Japan. So, but it varies from country to countries, and China has proposing different types of the connection. This is a number of the. This is a distribution of the CHAdeMO, the fast charging station in the world. CHAdeMO means I think this is originally developed by Japanese, and they know the origin of this name and CHAdeMO. CHAdeMO だったかな。charge the move だったかな。I think so. Charge the move or something. Yeah, that's truly the combination of the English and Japanese. Charge the move, CHAdeMO. And nowadays, so for many, mainly European or United States, so many CHAdeMO stations implemented. And this is a growth of the number of the CHAdeMO fast charging stations. I think target by Japanese government in 2020 was this line. But it's already achieved in the 2015. So the green line is number of CHAdeMO stations in Japan. It's about 6,000 in 2015. So it's about rapidly going up and up and up. So maybe already achieved the Japanese government prediction for the 2020. So at most, yeah. And the normal charging station is about 2 million in Japan. 2 million means 2 million. But in total. かな200万ってこれ日本だけだったっけステーションの数ちょっと分かんないね多分全国で200万あったっけなそんなになかった気がするんだけど I think this is maybe all over the world 200 2 million sorry yeah anyway so this is the global overview. So EV shifting in the world, what is happening? So, but as I talk in the first part of my talk and at the beginning of my talk, so as Norway and France and England, they are very, very active for shifting from the ICV to the EVs. Okay, for example, Norway has the government say that all vehicles will be electrified by 2025. I'm not sure it's possible, but they have very, very put a strong incentive for buying EVs. And the tax will be totally reduced. Maybe the 50% reduction of the tax can be get by purchasing EVs compared with the case of the purchasing the ICV gasoline vehicles. And also France and England, ICV, the gasoline vehicle will be prohibited before 2040s. So this is a very, very big impact for the OEM makers like a Toyota or something probably. So if this is still keep holding, so maybe in the very near future, the OEM will change the direction of the development of technologies. And China, so BYD is a very symbolic battery maker in China developing EV. So this is very, very active, and the government is pushing and supporting these companies to develop the new EVs. And nowadays, China government is also preparing the very good grid systems, power grid systems. Because if the many huge number of the EVs are installed in the society, so that one of the very critical problem is a kind of the power shortage. If everybody, China has so many populations, so if everybody charge the vehicles at the same time, for example, night nighttime. So what will happen? The Chinese power grid system at this moment is not so strong. It's not enough. So maybe it cannot support the charging of so many number of EVs. So China's government is now promoting the EVs. At the same time, they are now preparing the very strong power grid systems, preparing at any time, at any places. And so Japan. So considering the blending of the future vehicle types, as I showed in the table in maybe the second or third slide. So Japan is not only focusing on the BEVs, but also focusing on the combination of the future vehicles, ICV, gasoline vehicle, hybrid vehicle, PHV, BEV, FCV. And in some sense, this is very logical and reasonable because Japan is a car-making country. And Japan has a very strong advantage for developing the very complex cars. So in this case, maybe Japan does not want to lose that kind of strong point of the country. So that's why Japan is considering the blending of the future vehicle types like this one. So, but this is my personal opinion. So my personal opinion. So in Japan, the most realistic solutions in coming 10 years are probably PHV and the BEV with range extenders. So these two types will be one of the key player as an electrified vehicle in Japan. So they have the same characteristics as EV for short range, but they achieve longer driving distance thanks to the engine and generators. One of the common characteristics of PHV and BEV range extenders has they also both have engine and generators, not only the battery and motors, but they also have engine generators. As a result, size becomes a bit bigger and the system becomes a bit complex, but they have a very big advantage. EV characteristics for short range and achieve long drive distance. There is very, in some sense, very good combination, the reasonable combination for Japanese users, I think. So they can be used for the variety of the needs. And so this is one of my opinion. So maybe the PHV and BEV exchanger will be really more beneficial and very occupy so many dominant part of the Japanese car breakdown. But at this moment, a shift to the PHV is not so rapid in Japan. Still, HV is very common. Still, and ICV is very common. So why? And one of the reasons PHV is very high cost, of course, because it has a complex structures. Sometimes it's a big EV, sometimes it has a gasoline engine. So maybe it has very high cost because this is a hybrid, so it's very high cost. So more expensive than the same class hybrid vehicle by 7,000. This is coming from the size of the batteries because the size of the battery in the PHV is very big, so that's why. And the heavy weight and may degrade the fuel consumption rate. And also the important thing is that for users, it is very difficult to understand the benefit of the PHV over the existing HV. So what is the benefit of PHV compared with the HV? So PHV is originally designed to work as a pure EVs. I mean just a plug-in system. So maybe as a pure EV, PHV can drive maybe 50 kilometers or something. It's okay. So short distance, so it can drive as a pure EVs. But customers does not regard it is advantage to decide to purchase a PHV. So that is one of the big problems. So this is from technical viewpoint or environmental viewpoint. This is a very good idea. Short range and EV, long range and use a gasoline. So that's a very good idea. But from viewpoint of customers, so it is not still understandable, not acceptable by the customers. That is one of the very interesting problems. So need to charge. So on the other hand, the PHV is also need to charge both gasoline and electricity. So it's maybe more much more effort for providing the energy to the vehicles because they need both provide the gasoline and electricity. In the case of the hybrid vehicles, just providing the gasoline, it's okay. So gasoline and energy. So plug-in is some advantage to install the plug-in system or something? That is a very big question by the customers. So at this moment, the strongest competitor of the PHV is HV. That's a very funny structure about in the case of the selling the vehicles. Oh, I see. そうか、もうあと5 minutes だね。 This is the potential of the FCV. Maybe so I can talk about only first part. Sorry. Toyota FCV Mirai was released in 2014, and will FCV be post PHV? So the government policy is one of the interesting government policies is a diversification of the energy, because Japan is not energy producing countries. Japan is importing energies. So in that case, maybe it's only the fossil oil and only the coal or some other. So just a monotone energy resource is very, very dangerous. So Japanese government policy is to diversify the type of the energy sources. So in that case, one of the biggest promising energy source is fuel cell and hydrogen here. So from viewpoint of the diversification of the energy types, the FCV Mirai is has very, very big potential and will bring us a very big impact. But the question is how to generate the hydrogen. But it might be possible because we have already very big factories. Some big factories are generating the hydrogen, so it is possible to keep the generated hydrogen and to use it for the energy resource. It's okay, but only the problem is the establishment of the new facilities. But another important problem is how to implement enough number of hydrogen stations and who will operate it from business model viewpoints. That's one of the very, very big questions. Because hydrogen is not so easy to treat, it's not so easy to, for example, carry or install something. And once there is some accident in the hydrogen stations, so that will be a very, very big disasters, might be very big disasters. So very high level security systems, so also at the same time implemented for the hydrogen stations. That's why one of the, this is picked up the one of the biggest problems, the hydrogen implementation of the hydrogen station. This is a not so easy problem. So in order to implement more number of the FCVs, so maybe this problem will be solved. But if there are some ideas to manipulate and handle the hydrogen in very safety manners, so maybe the implementation of FCV will be accelerated. Okay, so I hope that's good. This part. And actually, so I have prepared the second part. This is the extension of the first talk of the Inak Sensei. But unfortunately, this time is almost up. And so if possible, so you have better look at the handout. And if you have some questions, please send me an email. So I will give you an answer. Okay. Okay, so there's a question about my talk. It's okay. I hope that you enjoy my talk. But so today I talk about very general talks on the, so not so specified one. Okay, thank you very much. So I'd like to close my session. Okay, thank you.